And what we're going to do is we're going to subtract mixed numbers here. Now, when we were adding mixed numbers, I always advocated that we use the separate method to add mixed numbers. Although both methods were acceptable, I just thought it was easier to choose the separate method for adding. Well, the opposite is also true for subtraction. I much prefer the conversion method when subtracting mixed numbers, and I'll show you why when we get to it. But first of all, let's subtract some numbers here. So we know that we can start off by going ahead and subtracting because we shouldn't have too much issue here. Our denominators are already the same. We're not going to have to find same denominators. So let's just do a quick conversion here. So we've got 4 times 5 is 20 plus 4 is 24. So we actually have 24 over 5 minus, well, 2 times 5. 2 times 5 is 10 plus 2 is 12 over 5. All right, well, now all we got to do is just subtract that out, and we get 24 minus 12, which is 12 over 5, which also equals 2 and 2/5. All right, simple enough. Easy peasy. Well, the separate method, it can be effective. It can be a decent thing, but there is one important step that often adds confusion for students when they're using this method, and I'll show you when we get there. So first thing we're going to do is we are going to separate. We're going to separate our whole numbers, and we are going to separate out our fractions. Okay, now there's actually 2 parts here that are going to be confusing, but I want to start off with the first part. The first part that you need to remember when you're doing this is that these numbers are already together and you've separated them. So in the end, you do actually have to add them back together. So you are going to perform your subtraction here and your subtraction here. And now that you've subtracted on both of those sides, you put them back together to come back and add them together to make your final answer. Okay, so what you've got here is you've got 4 minus 2 is 2, and you have to add that to 4 minus 2, which is 2/5, to get your final answer of 2 and 2/5. Well, that looks pretty easy, but we're going to take a look at an example here as to why the separate method can be even more confusing. So the first one is right here with this addition sign. A lot of students just add in a subtraction sign, which is actually incorrect, because if you subtract this, now you're subtracting twice instead of just subtracting what actually needs to be taken away. Now let's take a look at the second reason why I don't particularly like the separation method for subtraction of mixed numbers. All right, so what we've got here is we've got 4 and 1/3 minus, 4 and 1/3 minus, I've written it down wrong, minus 1 and 2/3. You can almost already start to see where the problem is here, but let's go through it. So what we've got is we're going to separate this out and say 4 minus 1 on this side, and remember that we have to add that, not subtract it. We add it to the other side, which is going to be 1/3 minus 2/3. All right, well, let's see here. What we've got is we've got 3 on this side, and we're going to add it to whatever's left here, which is 1/3 minus 2/3. Oh, we got ourselves a bit of a problem. We don't have enough here to take away 2 from. We've only got 1. We can't have 1 take away 2. So what we actually have to do is we have to borrow. So we're actually going to borrow one whole number from here. Now we know that one whole number represented over 3 is the same as saying 3 over 3. So we can say 3 over 3 plus the 1/3 that already exists minus the 2/3, And we only now have 2 left here instead of 3. Well, now we can actually solve this because we can say 3 plus 1 is 4. And so 3 plus 1 is 4, and 4 minus 2 is 2. So we can say that there's actually 2/3 left over. And now we have to add it to our whole numbers that are remaining, which is 2 2/3. Let's take a look at that exact same equation using the conversion method, and I think you'll start to see why it is that this is a simpler version when it comes to subtracting mixed numbers. All right, let's do a quick conversion here. 4 times 3 is 12, plus 1 is 13 over 3, minus 1 times 3 is 3, plus 2 is 5 over 3. And what we end up with here is 13 minus 5, which is 8 over 3, which converts to 2 2/3. Obviously, a much simpler and cleaner method, and a lot less room for error because you're not doing all of this borrowing in here in the separate method. All right, we're going to look at the conversion method here to help us solve this last equation. And this is a case where we know that we're already going to have to do some manipulation here because our denominators here are not the same. So let's start off by converting these into improper fractions. So a quick conversion, 5 times 2 is 10, plus 1 is 11 over 2. And then we're going to add that to, well, 3 times 3 is 9, plus 1 is 10 over 3. Okay, so what we've got here is we've got 11 over 2 plus 10 over 3, and as of right now we are comparing apples and oranges because our denominators are not the same. So we have to find our lowest common multiple between those two, and the lowest common multiple in this case is 6. So let's take this, we're going to multiply this by 3 to get it to 6, multiply this by 2, and now we have our new set of fractions. We're going to have 33 over 6. Whoops, I wrote a plus sign in here instead of a minus, minus 20 over 6, which gives us a final total of 13 over 6, which is the same as saying 2 1/6.